Okay, so in this one, we're going to take a look on how we can do 3D rotoscoping inside of Nuke when you have access to a 3D camera for your scene. So when you have a fast-moving scene like that with a lot of movement, you can use the 3D camera to project your roto on a geometry so that you only have very few keyframes to add for your rotoscoping. So we'll see various techniques on how we can apply our rotoscope on geometry using Project 3D and stabilized version of your plate that we can achieve with the 3D camera. So I'll assume that you have already watched the training on the lens distortion when doing 3D tracking, since we'll be using that inside this training as well. So let's start this training by looking at a few different ways we can achieve 3D rotoscoping inside of Nuke. Okay, so let's start by tracking this shot. So we'll just add a camera tracker. And the only thing that will be changing for the default value is that we want to specify that we don't know the lens distortion of this shot, so that Nuke will also solve the lens distortion as well as the camera movement. So we'll be able to use this lens distortion profile to do our rotoscoping on top of an undistorted plate without any distorted lines. So this will help us to do a more precise roto. So just make sure to specify unknown lens, and then you just click track. And again, this should be a very quick and easy track, since we have just some simple checkerboard cube in the scene, but we have a lot of lens distortion. So first we'll just solve the camera to see what kind of error we have. And since we have used this exact same footage in the lens distortion training, I know that we'll have a pretty good result of 0.65. So first thing we'll extract from the camera tracker is the lens distortion. So we'll just uncheck the link output so that we don't have linked expression to this camera tracker. And first we'll do the undistort so that we can undistort this footage. Then we'll also make a camera, of course. And we'll also make a quick point cloud so that we can see 3D position of our reference point. So we'll just select point cloud and create this as well. So now we see that we have pretty good reference to place our geometry in the scene. So we have our 2 cube here. So let's start by placing some geometries so that we can start the 3D rotoscoping process. So let's just say that we want to maybe roto, for this example, this side of the cube here. So there is various ways to create this geometry. The first one is by using the point cloud as a reference, and then you can create a new card and manually place the card based on what you see in the scene with the 3D point cloud. But as you can see, this is a very manual process, and you'll end up with some residual error. So this is a way you can use if you want to place your card manually based on the point cloud, but there's far better way that we'll just take a look now. So we'll just delete this card and go back in the camera tracker where we see our 2D track. So what you can do is select various tracking points like that is on the same plane that you want to roto on. So we'll just select a few reference points like that. And then what you can do is right click on one of them and select create card, and this will place a card. If we put it on the same scene as the point cloud, you'll see that Nuke has placed the card in the average position point that we have selected. So this will kind of do an average position, and you should have a card that is in the right place corresponding of the cube. So now that we have placed a geometry like that, let's take a look at one of the first way we can do 3D rotoscoping. So we'll go back in our 2D view where we have the undistorted footage. And what we'll do is we'll use this card to put some roto shape on it and then film this rotoscope with the shot camera. So we'll just make a new scanline render, and we'll put our camera in the camera input. For the object, we'll just put our card, and for the background, we'll just make a new reformat and make sure that we are using the same format as our plate. So we just make sure we take a look at the original plate. We see that we have 720. So we'll just make sure to use this same format in our scanline render. Then what we'll do is we'll make a new roto shape that will plug it directly inside the card like that. And while taking a look at the undistorted footage, we'll draw a shape that we want to track. So let's say that we want to rotate this part of this face here. So we'll just make a new shape and draw it on this frame like that. And then we'll just make sure that we output in all the channels. So RGBA, and we'll put that over our undistorted plate. So if we take a look at what we've got here out of the scanline render, we see that we have a shape that is kind of following the camera movement. But if we take a look at what we've got over the original plate, we see that what we have drawn on the frame is not matching the original shape that we've drawn on this frame. So the reason is pretty simple, is that you can't really put a roto shape directly on the card here, because basically when you apply this roto inside the card is mapping this input roto and its UV coordinate, and this won't match the original image in which you're rotoing on. To get a better idea of what Nuke is actually doing, let's just put the original image on top of the card and see what is the scanline render doing for us. You see that Nuke is taking the original image and mapping it to your card. So it's kind of stretching the footage on top of your card. So although you'll have a tracking roto that should be tracking your original shot, it will be very hard for you to actually roto and do any adjustment on that. So let's say you want to then adjust the rotoscope. You see that the UI is going kind of crazy when doing selection. So yeah, you can modify the shape, and once you have placed it, if you have a good and solid camera, it should be sticking to your cube. But as soon as you'll want to make some adjustment, if your camera is not project, you see that your selection is going crazy, since the coordinate of the card is not matching what is output out of this scanline render. So that's one way that I really don't want to use, but that's one that you can try if you want. But more time than the other, you'll end up with some crazy result like that. So it will be sticking to your geometry, but you'll have a very hard time to do some adjustment. Now let's take a look at another way that you can achieve 3D rotoscoping. So we'll just duplicate this to make our other setup. So basically you start again from the undistorted footage, and we'll just also duplicate our camera here. So what we'll do now is, instead of plugging directly the roto inside the geometry, what we can do is project our roto on top of the geometry. So this will be a bit easier, and we'll have a better output out of the UI to adjust it, but you'll see that you'll also have some downside. So it's not my preferred way, but I think it's a much better way than the rotoscope directly inside the geometry. So we have our camera. Now we'll do our project 3D to project the roto on top of the geometry. So now let's take a look at another way that we can place a geometry so that we can do some 3D rotoscoping. So the way that I prefer is with the model builder. So we'll use our model builder here and plug the undistorted plate as the source and use our camera that we have tracked for the cam input of the model builder. So now we'll just select a new card. And now let's say that this time we want to roto on top of this face here. So like I was explaining in the lens distortion training, what I like to do is not place the very corner of this geometry here to what I want to roto on, but instead use the inside point of the geometry so that we have some headroom outside our roto region. So instead of placing the four corner here, what I'll do is place the inside corner like that. So let's say I want to roto this part of the face here. So I'll just place the inside part of the card here on top of our reference point. Something like that. So now if I ever have to adjust the roto maybe a bit outside here, I have some geometry to project my roto on. But if I place this corner directly here and that my shape needs to be a bit outside of it, then I don't have any geometry to project on. So I think it's a good habit to leave you some headroom with the model builder. So we'll just place it on another frame. So we'll just replace our reference like that. So now we should have pretty good geometry to project our rotoscope on. So now that we have our model builder, what we can do is extract this geometry. So we'll select the card and go in the select geometry here and click on bake. So now we have a geometry that we can project on. You could also use the model builder directly to project on it, but then you would have to use the apply material instead of the project 3D. So let's just use this geometry, and for the texture now we'll put our lens distortion here, and for the camera we'll use our shot camera here. So we'll plug the camera, and then we'll have to put a frame hold to our desired projecting frame. So let's say that frame 18 is our desired frame here. So we'll make a frame hold just after the camera and put our frame here. Now we'll put our roto just after the lens distortion, and we'll just draw our roto shape. So we'll just draw this shape here like that. And then we'll make sure to click on replace, so that if your input image has already an alpha channel, you'll be replacing it with what the roto is giving you. So now we have a roto that we can project on top of our model builder. So we're frame holding the camera, but we'll leave the animated roto so that if we have some adjustment to do, we won't have a frame holding what we have on a single frame on our roto, so we'll be able to do some adjustment. But if you put your frame hold after the project 3D, even if you do some keyframing on your roto to do the adjustment, the frame hold will just kill all those keyframe and keep what you have specified in the frame hold. So we'll just put it after the camera, and then we'll put our project 3D on top of our model builder geometry. Next, we'll call our scanline render, and we'll put the object inside the object input. Then we'll use the shot camera inside the camera input, and again, make sure that you're using the right format for your scanline background input. So just make sure you're using the same format as your plate. So now if we take a look at what we've got from the scanline render, if we take a look on the alpha channel, we see that we have our roto here, and we'll see that we still see the RGB since our roto is just overriding what we have in the alpha channel. So if you only want the alpha to be output, you can also replace the RGB. So now we see that we have our roto here that is following the face of the cube. So to test this setup, we'll just make a new gray node and connect our original plate, but we'll use the undistort. And then to test if it's threading, we'll use the output of the scanline render inside the mask input, and we'll just do a very quick color correct to see if it's sticking to the geometry. So if we move in the shot, we see that we have our roto shape sticking to the face of the cube. But now you see that we have our shape is slipping just a bit near the end of the shot. So now if you want to adjust the roto shape, if we double click on the shape here, you see that we still have a UI problem, and that the shape, even though we can select it, is not aligning with the output of the scanline render. So that's one problem that I don't really like with this setup, is that if you need to do some tweaking, you'll have to select the point a bit off from where it should be landing. So even though you can still adjust it like that, so now you could just do some tweaking like that, but like you see, you have to adjust it really off from the original position. So it's kind of, if you have a lot of keyframe to tweak, this can be quite annoying. So, but right now we just have 2 keyframe, and most often when you have a good camera, you won't need to do much adjustment. So you see that by just projecting a rotoscoping shape like that, you're pretty much all set, and you really don't have much adjustment to do. But imagine all the work that you will have to do if you were manually placing your shape on a moving camera like that. So you see that by using this very easy projection setup, we have simplified the rotoscoping process quite a bit. Now let's take a look at the third way of doing 3D rotoscoping inside of Nuke. So the idea behind this technique is to do a 3D stabilization of your plate instead of doing a 3D projection on top of your footage. So by doing a 3D stabilization, you'll be able to rotoscope on top of this stabilized version of it. And this has a few advantages, like not having the UI problem that we have with the other technique, but also you won't be moving everywhere in your viewer to do the adjustment on your shape. So since you have a 3D stabilized version of it, basically you won't be moving in your viewer to do the adjustment, since the footage will be stabilized. So let's take a look on how we can achieve this technique. So again, we'll just duplicate our plate with our lens distortion as well as the shot camera, and we'll also duplicate the geometry that we've made inside the model builder. So we'll start from the setup, and then what we'll do is make a project 3D, but this time instead of frame holding the camera and projecting on top of the geometry, what we'll do is we'll still use the original plate, but now we'll project using the animated camera. So by using the animated camera on top of this geometry, what we'll be doing is a stabilized version of the footage instead of a normal projection. So to continue on the setup, we'll just make a scanline render and connect the camera as well as the geometry. And as always, make sure you're using the same format as your plate. So now the only thing we'll change is we'll make a frame hold, but this time not for the projection, but for the scanline render. So basically what you're putting in this frame hold is the reference frame you want to base your 3D stabilization on. So for example, if we take a look at the lens distortion and that we want to stabilize based on frame 5 here, if you put 5 in the frame hold, and now we take a look at what we've got in the scanline render, we see that for frame 5, there is no filtering applying and no transformation. But now, if we move in the viewer, you see that we have a stabilized version of the face of the cube here. So everything outside this face is moving, but you see that the face here has been stabilized. So now we can use this stabilized version to do our rotoscoping on. So now that we have a stabilized version of this plate here, now we can put our roto just under the scanline render and start to draw our roto shape. So we'll go at frame 5, select the bezier here, and we'll just draw a very simple shape like that. So again, we'll make sure to replace the alpha. So now we have only the alpha from the roto. And now, since the footage has been stabilized, if we move here, we see that our roto shape is sticking to the face of the cube. So like I was saying before, if you need to do some adjustment here, normally with the other setup, if we go back to this one here and take a look here, and let's say we want to tweak this, if you zoom here to be really precise and move in the viewer, you see that this point here is still moving in the viewer, so you'll have to zoom out and find the corresponding roto point. But with this technique here, you see that since the footage is stabilized, I can really focus on this point here. And now if we move it in time, we see that I don't have to move around in the viewer. I can just check this point. If I need to do some adjustment, just move it like that and continue to do the final tweaking like that. So you don't have to mess around in the viewer. So that's one advantage that I find using this technique. And we also see that since we are doing the roto in 2D here, since we are out of the scanline render, we don't have any UI mismatch with our shape here. So what you select is what you get. So now that we've done our roto on our stabilize, we need to reapply it to our geometry. So now that we have a moving shape instead of a stabilized one. So what you can do is do another project 3D. Use the roto here, but this time now we're back in our usual project 3D setup. So we'll duplicate this camera, and actually let's not duplicate this camera, but we'll use the exact same frame old camera that we are stabilize our plate based on. So we'll use the same shot camera with the frame old that will project our roto on, and then we can either duplicate this geometry and put it under the project 3D, or we can just use the apply material to use the same geometry so that we don't have to duplicate this geometry. So we'll use this as the material and we'll apply it on our original model builder geometry. So we'll just connect it to the same model builder here. So now we are applying the project 3D inside the model builder. So we'll make a new scanline render, film this roto, again with the same format, but this time we'll film with the animated camera. So now that we're projecting our stabilized version of the roto on a single using a frozen camera, now we should have our roto back following the original movement of the plate. So just to test this setup, again, we'll make a new grain node, and connect the lens distortion here, and we'll use the roto to do the masking of the grade. So we'll just go back here, do a quick gain here, and now we see that our roto shape is following the original plate. So of course now, if you need to do adjustment, you won't do it in context like that, since now we got back to the original projection problem, which is the UI is not matching up with what the scanline render is outputting. So if you need to do some adjustment, just make sure to go here in the roto to do the adjustment on this stabilize, so we'll have our UI matching our stabilized footage. So one last thing we want to tweak is now we're applying the roto on the undistorted footage, but now let's say that we want to do the grading on the original distorted plate. What we'll do instead is, instead of connecting it to the lens distortion, we'll connect to the original plate. But what we'll do instead is we'll just use this lens distortion to apply the distortion to our rotoscope. So we'll put the lens distortion right under the scanline render, and instead of leaving it to undistort, we'll click on it, which will distort the roto shape so that it matches the original distortion of the plate. And as usual, when distorting something out of the scanline render, make sure to give the scanline render some overscan so that if the roto is going out at some point of the canvas, the information outside of it will be there for the distortion to bend it back in the original image. So make sure that in the overscan you have some pixel headroom. So now we should have the original distorted plate, but now with our roto that is matching the distorted footage. Now, there's one last trick I want to show you. Since we've used frame 5 here, which was a frame where the cube was pretty far in the plate as compared to the end here, let's take a look at the actual quality that we have out of the scanline render. So let's go back at frame 5 and take a look at the scanline render and take a look at actually this scanline render and take a look at the quality of the shape. So at frame 5 we have a pretty good quality, but let's take a look at what happened at the end of the clip. We see that we have lost quite a few detail in our roto, and that's because we are projecting on a frame, which is frame 5, where the geometry is pretty far in the scene. So when the second camera is filming back the projection, the geometry is getting very close to the camera and the actual roto is lacking a lot of resolution. So there's one easy trick to fix this if you notice after your roto that you still need a bit more resolution like that. So the trick is to go back once you have finished your roto, or you can actually do it before, but if you ever notice after the roto that you are lacking some resolution, go in your scanline render here where you have the stabilized version of your shot and just put a very quick reformat in scale mode. So the idea is to raise the resolution of this image here. So right now we're in 720 HD. So we'll just raise this number to 5. So basically now we have multiplied this resolution by 5. But now we'll see that the roto is not matching our upscale version of the plate. So how can we make this shape here go back to where it should be landing on this upscale version? And the trick is actually quite simple. You just go in your roto node and you click on your group where the shape is on. So we'll click on the root here and go in transform. And what we'll want to do is to scale the group here, but based on the bottom left corner here. So pretty much like the reformat is doing, which is scaling from this corner here, we'll simulate the same thing on this roto so that when we scale this group, it will be matching to our upscale version. So basically, you just select the group in which your roto is on, and we'll reset the anchor point to 0, 0. And then in the scale here, you just match what you have put in the reformat. So since we have put 5, we'll put the same number. So now you see that the roto shape is back where it should be landing on the face of the cube. So now if we take a look on what we've got out of this scanline render where we were lacking some resolution. So we'll just go back here and take a look at the actual quality that we have out of the scanline render. So that's with the upscale of 5. And if we reset it to what we have, so we'll put back 1 here and 1 here. So you see that's the difference that we have. So we can also automate the link between the scale factor of the roto and the reformat. So what we can do is instead of hard coding a value here, we can just put a quick expression and we'll link the scale of the group to the reformat. So we'll put reformat 5.scale. So now we see that if I modify the scale of this reformat, you see that the roto is still fitting since it's adjusting the scaling live based on this expression. So now that we have made this expression, we can go here and just use the desired scale factor that we need to get a good resolution. So now all you have to do is go in your reformat, raise this number until you find that your rotoscoping edges here are looking the way they should be. So that's one trick you can use if you find that for some reason you projected on a frame where the roto was too far away, but that at the end you're lacking some resolution. So here again, you see that at frame 50, we have some rough edge. So go at the frame where you need more resolution and just upscale the reformat here until you get the result that you want. And the very last thing that we'll do to make this setup perfect is to add motion blur to our roto shape. Because right now we're doing our roto on a stabilized version of the plate. So basically our shape are barely moving. So we'll definitely need to add motion blur if the original footage had motion blur. So what we can do now is simply go after the final scanline render here, add a motion 3D node, and connect the original camera. So now this motion 3D node will output motion vector that we'll be able to use with the vector blur. So just make sure to output your UV in a channel. So by default, it's outputting in the motion channel. And then just put a vector blur node and make sure to select the same channel. So we use motion. So now if we take a look at the part where the scene was moving quite a lot, take a look at the alpha channel. So that's the version without motion blur. And now we see that with the vector blur now, we can raise the slider here to get some motion blur out of your scanline render. So that's one way you can add a motion blur to your rotoscope so that it match the original plate. Another way you can use is directly inside the scanline render, and is to raise the sample of the scanline render. So you'll see that when you raise this number, you'll be starting to see some motion blur out of it. So if we go in a region where the footage is moving quite a lot, and that we raise the shutter, you see that we're generating also some kind of motion blur. So that's another way you can reapply motion blur to your rotoscope. And of course, one way also you could add some motion blur is with the RSMB motion blur plugin. So you would analyze the original footage and reapply motion blur based on the vector that the Real Smart Motion Blur plugin would be giving you. So I hope you see the great potential of those 3D rotoscoping technique, and I hope you'll be able to use it in your shot.